All right, so let's look at 5.5 notes. There we go. There is one more shortcut that we are going to talk about today, and it's in our 5.5 notes. So our goal for today is to prove triangles congruent by the HL theorem. So the first thing that we're going to do is we're going to talk about the different parts of a right triangle. Does anyone remember what any of the sides are called in a right triangle? Any of that vocabulary from right triangles ringing a bell? It's been a while. Hypotenuse is one of them. Do we remember where the hypotenuse? And then the legs, yep. So we have the legs and the hypotenuse. Do we remember which is which? How to tell where the hypotenuse is compared to? Go ahead, Ian.
The hypotenuse is the diagonal.
It's the diagonal one. If you find the right angle, okay, so find the right angle, go across from it, that's always going to be your hypotenuse. H-Y, P-O-T, E-N-U-S-E. It's all smaller words. High, pot, then the T becomes 10, use. I heard one of you guys say, how do you spell that? Okay, so that's the hypotenuse. That means that these other two sides are what we call legs. So that's a leg, and this is a leg. Okay. Now I turned the triangle. It's facing a different direction. It doesn't look like a standard right triangle. So go ahead and see if you can label the hypotenuse and the leg on this one. How'd you do? Did we get it? Give me like a 1 through 5. I can label the hypotenuse and the legs of a right triangle. All right, that's the big idea here, is you're going to have to be able to do that. Okay, so the hypotenuse leg theorem, it says, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So if we look at what we have labeled here, we have a right triangle. We have the hypotenuse. You can even mark it. Write it in. Hypotenuse. Leg. Leg. So we have a hypotenuse congruent to a hypotenuse and a leg congruent to a leg. And because of that, and we have right triangles, we can see that because we were able to label on a hypotenuse because of that right angle. Okay, then we can say that triangle, name the first one however you want, A, B, C, is congruent to, be careful when you go to name the second one because you could get this wrong. A has to match with, A is the right angle, it has to match with the other right angle, which is D. B has to match with E, and then C will have to match with F. So when you go to the unmarked angle, through the hypotenuse, or through the unmarked side, through the marked hypotenuse, okay, you have to make sure you go in the same order. So D, E, F on this one. Okay, you have to make sure that everything is accurate. Order matters. This unit is a big thing. Order matters. All right. So we're going to do an example here. And then we have a couple proofs and to figure out how to use hypotenuse leg theorem to prove triangles congruent. So again, we've been doing proofs with shortcuts, our triangle shortcuts. And we've been doing pretty good with those. Now we're going to do the same idea, but we have another shortcut to use, and it's the HL theorem, the hypotenuse leg theorem. Okay. So we are given here that CD is congruent to EA. So I would start by taking CD and marking it congruent to EA. So CD is marked congruent to EA. Now this next sentence says that AD is the perpendicular bisector of CE. What does a perpendicular bisector give you? It gives us right angles. What else does it give us? The perpendicular part tells us, what's that? It's going to give us some equal sides because if it's a bisector, it's cutting something in half. So AD is the perpendicular bisector. So I'm going to highlight AD because that's the thing that is cutting it in half. AD is like the knife that cuts the sandwich in half. Okay, so what's the sandwich then? What am I going to mark if it's bisecting CE? What can I mark in my diagram here? No. I'm not going to mark that AB and DB are equal in this one. Go ahead, Kyla. Yes. These are our congruent segments. That's the knife that cut the sandwich in half. Okay? That's the line on our sandwich. But we have to mark our sandwich. This half is congruent to that half. Do you see the difference? That's why I highlighted the bisector. What is it that it's cutting in half? That's doing the cutting. Okay, and that's a huge misunderstanding is what is actually being cut in half when we have perpendicular bisectors. You have to be very, very careful here. Okay, so AD is the perpendicular bisector, so that's the knife that cuts CE in half. That allows us to mark that. But what else? We said that it also forms a right angle. So what can we write as right angles? Go ahead.
Angle ABE and CBE.
Yep. ABE and CBD. That's what you said, right? Both of those are right angles. Yep, that looks good. Okay. Now, see how we can see that we have right triangles. Do you see how we have a right triangle here and a right triangle here? In order to use the HL theorem, we, one, have to have right triangles. That's a big thing. Two, we need to make sure that the hypotenuse is marked congruent. So let's look at this right triangle down here. And let's label the H for hypotenuse. That'll be a little bit easier than writing out the whole word. Okay, that means that this is a leg. All right. Looking at this one, is that a right triangle? Go across from the right angle. Let's label the hypotenuse. Let's label a leg. Obviously, the unmarked one is also a leg because they have two legs, but that's not that important here. Okay, so in this triangle here, what do I have labeled? What's the shortcut that I have labeled there? Side-side angle. What do we know, though, about side-side angle? It cannot be determined. However, this is a special scenario where side-side angle will work because it's a right triangle. I don't just have side-side angle labeled. What I actually have labeled is a hypotenuse and a leg. So I actually have the shortcut HL. In this one, I also have HL labeled. The hypotenuse is congruent to the hypotenuse and a leg is congruent to a leg. Because of that, I don't even have to think about that SSA theorem or shortcut that doesn't work because I can use HL. So I can mark these two triangles congruent. Triangle BCD is congruent to triangle. How would I name the other one if I started this one as BCD? I started with the right angle, start with the right angle, go through the double dash, go through the double dash. So B, E, A. By, what was the shortcut I used this time? Because I didn't use SSA because we know SSA doesn't work. I used HL. There's another shortcut that will work. So we can add that to our list. Remember we've made those lists of shortcuts that work and do not work? That's going to be one that you're going to want in your does work shortcut. Okay. All right, let's flip that over. And let's look at these proofs that we have to do. first thing I'm going to look at here is I have that WJ is congruent to KZ. Well, I have something marked congruent. I might as well mark it on my diagram right now while I'm there. WJ is right here. KZ is over here. Okay, what was my reason there? Given. All right, I also have that angle W and angle K are right angles. What was my reason? Given. Let's also label that in our diagram. Angle W is a right angle and angle K is a right angle. Okay. You guys should see this other thing that I can mark in my diagram. It's that obvious one that sometimes we miss because it's so obvious. The shared side. How would I write that shared side is congruent to the shared side? How should I name them?
JZ.
Let's double check. JZ is how I'm going to name the first one. Now look at your congruent statement up here. Does J line up with J on the other triangle? No, what's it line up with? The Z, so our Z has to come first on the next one. What does Z line up with? J. So this one has to be JZ is congruent to ZJ. That's why order matters. You have to look at your actual statement and figure out what are we trying to prove. Which points line up with which points. Do you see the difference? All right, so we have that. This next one is the extra piece of information. So remember how on all the shortcuts we have to have three things labeled congruent? HL is a little bit shorter because you only need two things labeled congruent, but you still need three pieces of information. That third piece of information is stating that they are right triangles. Okay, so in all the other shortcuts, you needed three congruent things. In the HL theorem, you need two congruent things, but the third important thing is to state that they are right triangles. So this here, we have to look and say, okay, I know that my overall, I'm trying to prove that triangle JWZ is congruent to triangle ZKJ. And I don't know my reason yet, even though I'm pretty sure it's going to be HL theorem, considering that's the section that I'm in, okay? But when I look at that, I'm going to look up here at this triangle, JWZ. Is this a right triangle? Yes, okay? I do have SSA labeled, but SSA is not a shortcut that works. So is it a right triangle? Yes. Do I have a hypotenuse and a leg labeled? Yes, so I have HL over here. Looking at this one, I have SSA labeled. We don't care about that though because that shortcut doesn't work. So look at it. Do we have a right triangle? Yes. Do you have the hypotenuse and the leg labeled? Yes. So you have HL. So we can see that we're going to have the HL theorem, and then the only thing that we're missing is that we never stated that the triangles are right triangles. So we need to go back and say that triangle JWZ and triangle ZKJ are right triangles by the definition of a right triangle. The definition of a right triangle just says it's a triangle that contains a right angle. Those are both triangles. They contain a right angle. We can see that. So by the definition, we know that they're right triangles. Yes, go ahead.
So how do you know if it's side-side angle or...
You can't use side-side angle. Remember side-side angle, if I write it, it's a bad word backwards, it's a bad shortcut, you can't use it. So if you get to this point where you're at side-side angle or SSA, you say, okay, well then either it cannot be determined or I can check to see if they're right angles or if they're right triangles, and if they are, I might be able to use the HL theorem. Does that make sense? Did that answer your question too?
Kind of.
Okay, what was your question?
HL only work
Yes. Because even if it was the other leg, you'll still have a side, and the right angle is your angle. You always have to have the right angle there. Okay. Now let's say we had both the legs. Then actually, what would you have? What shortcut if I labeled? I'd have side, angle, side, which is a shortcut that works. So I would then use side, angle, side, not an HL theorem, because I wouldn't have the hypotenuse. Does that make sense? Yeah. All right, should we try the other proof? All right, so scooching it on down. We have that D is a midpoint of AS and BO. So let me write that first. D is a midpoint of AS and BO. The reason? Given. I have that angle BDA is a right angle. Given. I know that I'm trying to prove that triangle BAD is congruent to triangle OSD. I don't know my reason yet, though. That's everything I can fill out right away. I already have 5 points out of a 12-point proof just from my setup. That's kind of cool, I think anyways. I just have to kind of fill in the blanks from there. Are we okay with that? So far, so good? All right, so let's read the first given and see what it is we can label. It says D is a midpoint of AS. If D is the midpoint of AS, what can you label? Go ahead.
AD and BS.
Yes, so mark them congruent, but now let's go back and actually use our statement to make sure we have things in the right order. So you said AD is congruent to, look at your congruent statement here. What does the A have to line up with? A has to line up with S, so S has to come first. What does D have to line up with? D. So when we go to write this, yes, you can think about it and say it however you want up here when you label it, but before you write it down here, make sure you put things in the right order based on this congruent statement. Okay? What was our reasoning? We said that D is a midpoint of AS, so we labeled those congruent. What's the reason then? The definition of a midpoint. I'm going to keep reading this. It says D is a midpoint of AS. We took care of that. And BO. This is an O right here. It's hard to see. There's that whole bunch. What else can you label then if D is a midpoint of BO? Yeah, these ones are also congruent. Okay? Now, be careful. We set them in a random way. BD is congruent to OD. Yes, to label them, but let's make sure that that's actually in the right order. So BD is congruent to, B has to line up with O, and D has to line up with D, so we have to make sure that those are in the right order. What's my reasoning on that one? Definition of midpoint again. I also know that BDA is a right angle. Well, I can just label that right on my diagram here. That is what that says. I don't have to put that as I don't have to write BDA as a right angle again. That's literally what it said. Okay. What else can you label on this diagram? Griffin?
SBO is a right angle.
Why?
Vertical angle.
What does the vertical angle theorem say? So you want to say this is a right angle because of vertical angle theorem. Okay. What does the vertical angle theorem actually say? Not about parallel lines. If two angles are vertical angles, then they are congruent. So I have to instead say that, let me change my color here. Orange. I can say that angle BDA is congruent to angle ODS because of the vertical angle theorem. You can use the vertical angle theorem to say that this angle and this angle are congruent. Then we could say that since this is a right angle, that's also a right angle. But I have to say that those angles are congruent if I'm using vertical angle theorem. Because the vertical angle theorem says if two angles are vertical angles, then they are congruent. So if I'm using vertical angle theorem, I have to say that the two angles are congruent. And you'll see why we don't necessarily have to even say that it's a right angle. What is our shortcut that we have labeled on that top triangle? Kyla?
Side angle side.
Side angle side. What is the shortcut that we have labeled on this triangle? So I could have said that those are right triangles, but did I need to? No, because side angle side is what's allowing me to say that these two triangles are congruent. Because side angle side is a shortcut that worked. I didn't have to prove that they were right triangles and then say the HL theorem. You see the difference? So just because they're right triangles does not mean it's always going to be the HL theorem. You have to still show your three things, whether it's three sides, two sides and an angle, one side and two angles, or three angles, or two angles and a side, or one angle and two sides, whatever. All your three different combinations. If it doesn't work, if you have something like angle, 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 or side, side, angle, then we have to say, okay, well, that route didn't work. If you're at side, side, angle, you can then look and say, can I say that they're right triangles? If they are, then you have that piece of information to use the HL theorem. Angle, angle, angle is never going to work. So, do we have questions on this? All right, so then if you look at the next assignment, it has some guided proofs for you. 1 and 2 says, what additional information would you need in order to prove using the HL theorem? So label that additional information. Number 3 and 4 are proofs. Number 3, the proof is pretty much done for you. You just have to go in through and say, okay, if this is what I'm given and I can mark this, what would be my reasoning? Okay, based on that, I can say this, what would be my reasoning? Okay, so the boxes are all your statements. Underneath it are your reasons. Why can you say those things? Okay, it's just a flow chart proof instead of a 2-column proof. Number 4 is another proof. 5 is a guided proof. There's just, there's some hints in there that should help you. That one's a little bit trickier. Number 6 is another one. And then the rest of them are determining whether or not you can use the HL theorem. And 10 and 11 are story problems with diagrams that look like triangles, so you don't even have to pretend that they're story problems. Or I guess you can pretend that they are not story problems, is what I'm saying. So if you have questions, let me know.